I picked up a grocery order at Whole Foods this morning, and it made me think we should do some functional programming. In this video, we're gonna walk through an example of kind of a grocery receipt and slicing and dicing the data using functional programming techniques in JavaScript, specifically filter, map, and reduce. So let's jump in. By the way, today I'm going to be using Run.js. Run.js is a really cool app you can download for Mac, Windows, or even Linux. And it allows you to type code on one side and immediately see the values on the other side. So just wanted to give you that quick tip. What we're going to do today is take a set of data and transform it using filter, map, and reduce functions. In our example, we have an array of items here which represent what you might see on a grocery receipt. These happen to be the items that I picked up this morning. So we have apple, banana, almond milk, peanut butter, avocados, etc. These happen to be a lot of my ingredients to smoothies. I have several questions down below that we're going to use filter, map, and reduce to answer. Each item has a label, a category, a quantity, and the item price. Down below, we have several questions we'll be answering with filter, map, and reduce. So let's go to the first one. The first question is, how many produce products are there? This is a great use case for filter. Filter is a function that operates on an array and filters it down based upon a condition. So if I take my array items here and do dot filter on it, what you pass into filter is a function that's called one time for every single item in the array, and it passes that item into the function. So let's pass in an arrow function here that takes one argument of item and returns a Boolean, a true or false, or truthy or falsy, based upon whether that should be included in the resulting array or excluded in the resulting array. If it returns true, then that item will be included in the resulting array. So if we want to know how many produce products there are, then I can take this item's category and compare it to the string produce. And that will filter down our array to only the products that are in the produce category. Now, an important thing to understand here is that this hasn't changed our original array. If I come down here and I just output the items array again, we still have all of those items in the original array. Filter has actually produced a new array and only included the items that match this condition. So let's actually finish off our question here. The question is how many produce products? Well, we have an array of 5 items, and I don't want to know the quantities right now. I don't know overall how many products. So since this is an array, I can just do a dot length on it. And we have 5. So we have 5 produce products on our receipt. Next one. Which items are over $5 each? This is another great use case for filter because we're including and excluding various items. So once again, if I do items.filter, I pass in a function that takes one argument of item, and the condition here is whether or not an item is over $5. So I'm going to do item.price is more than $5. So once again, this will return an array with only the items where the prices are over $5. Great, moving right along. How many products are being purchased in multiples? So what I really want to know here is how many items have a quantity of more than one. So this is very similar to our one above, where we are once again using filter, passing an item and saying quantity where that's more than one. And we have these 3 products. Now the question was actually how many products are being purchased in multiples. So once again, I could do dot length on that. And I can see that, if I line this up a bit, I can see that we have 3 products that we're purchasing more than one of. Okay, so that's 3 examples of using filter. Let's move along and learn about the map function. Our next question is, what is the total for each product? So In our list of data here, we have both a quantity and a price, where the price represents the item price, what each item costs, not what the total costs. So in order to get a total, we really need to multiply these together. So what we want to take in is this array of items, and what we want to output is actually another array of items that includes the total. So that is a great use case for the map function. Like the filter function, the map function exists on an array, and you pass to it a function that is called for each individual item. So if I call map and it gets passed an item, then what I return will transform that element of the array. I think it will make more sense when we see it in action. So if I want to return, let's return both the label of the item and say total. So let's return label, item.label, and then total will be the item.quantity times the item.price. So now once again we have a brand new array, and this time we have just the label and then the total. So what map has done is it has iterated over each element of this array, called the function that we passed into map each time for each individual item. And the value that's returned from that function becomes the item that's outputted in the array. Let's move on to another example. So this one is, let's relabel to category : item label. So maybe you're printing something to screen or printing out a receipt, and you need to kind of format the text here. This is another great use case for map. So I'll call items.map, and for each item, I'm going to return a string. So we'll use our backticks for a string literal here, where we start with the item.category, then we do a colon, and then we do the item.label. So this returns not an array of objects like we've been working with, but instead an array of strings, because we return in a string from this function inside of map. And we simply have category, item label. So those are a few examples of how to use map. Let's move on to reduce. Now, reduce is usually what scares people. It's kind of the hardest to wrap your brain around. Don't worry, we're gonna go over it step by step, and hopefully you'll be a pro at the end of this. So our next question is, what is the highest priced item? For this question, we want to only return a single item. So our input is this array of many different items, but we only want to know the one highest priced item. So we're taking a list of things, but we're outputting only one thing. And you might think of that as we are reducing a full list of items down to just one thing based upon a condition. So that's a good use case for the reduce function. Let's walk through it. Like the others, reduce is a function on item, and you pass to it yet another function. However, this time, instead of just one argument of the item, the reducing function is actually passed two arguments. Like the others, you pass a function to reduce. But instead of that function being called with one argument, there are actually two arguments it's called with. And the first value is an accumulator value. And I'll explain what that is in just a moment. How reduce operates is the value that's returned from this function is then passed to the next iteration of this function being called as that accumulator value. So if you think about our question here, what is the highest priced item? Essentially what we want to do in this list is go down the list and compare, is this one greater or is this one greater? Is this one greater or is this one greater? And we can do that here in the reduce function. So for each item, if the item's price is greater than the previous item price, I'm going to call this previous, then return this new item. Otherwise, return the previous item. So let's wrap our heads around that a bit. And we can see I have in fact gotten the highest price item down here. What this has done is this has helped us to compare each item in this list, where we're first passed in our original item, and then each item in the list beyond that. We can compare the price of the two and simply return whichever one is the highest priced. The highest priced one is then passed in as the previous item next time around. Let's go over a few more examples. So let's say we wanted to group products by category. So we wanted to build up, this time, an object where the key is the category of the food and the value is an array of all the items. Because we're transforming our data from our list of items to a single object, that's another use case for the reduce function. So if I call items.reduce, I'm going to have an accumulator value and each item one at a time. In this case, I want to build up an object. It helps to sometimes rename your accumulator variable to something that makes more sense. So I'm going to rename this to groups. And I want groups to be an object. Well, in the reduce function, you can pass a second argument overall here, which is your initial value. And I want to initialize the groups variable as just an empty object. So from this function, we will return an object that consists of everything that's already in groups, because remember that we could be several iterations deep here and have already built this up. And then what I want to do is, in each iteration here, add a key for that item's category. So I'm going to use the square brackets syntax here to add a key for that item's category. And in it, we want to place that item. Now, what you'll see here, it's a few things are running together, but this is the answer. What you'll see here is that now I only have one item in the category. And that's because I'm literally overriding that each time here. So I need to go ahead and include anything that might have previously been placed in that group. So let's see. So let's make a variable called previous items. And this is the items that already exist in that category. So for our groups in that given category, return this array that might not exist. So let's go ahead and say or a new array. And then append our previous items to the front of it. So now we have an object that is the key for each category and a value of all of the items in that category. Once again, no data was mutated here. We didn't reach into any objects and manipulate their keys and values. Everything that we're building up here is actually a new object or a new array. And this adheres to that functional style. A similar question below, how many products per category? This is very close to what we have above, but instead we want totals for each category. So let's use items.reduce again. Once again, our accumulator we'll call groups, and this function will be called for each item. And we'll once again start with an object because we want to build up an object with values that represent the categories. So what we want to return is a new object, including the values that are already on groups. And then we once again want to take the current items category and add 1 to it. Now, you'll see like we had before, I only have 1s for each of these, but I want to also add up however many other items were already accumulated in that category. So let's make a function called previous total, and we will grab from the groups object, from the key of the items category, however many total items there already were. Now, that might not exist yet, so we will initialize this to 0 if not. Then we can take our previous total and add 1 to it. Now we have a count of how many items are in each category. We have 5 produce items, 2 dairy items, 2 snacks, and 2 frozen items. Now that question was how many products per category, but I want to know now how many baggable items there are in total. For this example, we're going to use several different of a few different of the functions that we've learned so far in order to make this work. So how many baggable items are there? That means I want to count 1 for every quantity number in here. So this is 1 baggable item, this is 4 baggable items, so together that's 5 baggable items. So I essentially want to sum up all of the quantities together. So we're going to use 2 different functions for this, both map and reduce. First, let's map over the list. So we have our list of items. Let's map over the list and extract out only the quantity number. So that we can do with a simple map, pass in each item, and we'll extract from that the item quantity. So what this gives us now is an array of just numbers, 1 number for each quantity item in here. This is a really frequent use case of map, is to extract out just one of the values from objects. Now we want to take all those values and add them up together. That's a great use case for a reduce function. And this one might be a little easier to understand. So I can chain these together because items is an array. I can call .map on an array. .map returns another array, which I can then call reduce on. So this is called a chain. I'm chaining the map and reduce functions together. So we're going to have some sort of accumulator value. We'll go over that. We're going to pass in each item. And then we want to return some number. And let's say that we want to also initialize this to 0. So our accumulator in this case is going to represent our total, or the total number of items. We're going to initialize it to 0. And what we want to add to it each time is the item's quantity. So we're going to take our current total and add to that the item's quantity, which came up as not a number. Oh, I forgot. So I'm only returning quantity here, which is a number, instead of the whole item object itself. So instead of this item being an object, it's just simply a number. So I'm going to call this num, and we just need to add these together. There we go. Now this returns 18. We have 18 baggable items that need to be bagged. We have 18 baggable items, so if we're putting things in a bag, we can count and make sure they're all there. Couple more. Let's get a total price for our entire receipt. So that involves a couple of different steps here. First, we have the item price and we have quantity here. So we need to multiply these two together. to get the total price for each item. And then we need to add all those total prices together. So very similar to the last one, we're going to use multiple functions here. So we'll start with our items array. We'll use the map function and let's map over each item and return that item's total. So for each item, let's return its quantity times its price. So this will give us an array of total prices for each item. Now we want to simply add up all these numbers together. Now let's do something to save us a little time here, or maybe it's not time, but save us some repeat programming here. This function up here where we answered how many baggable items. This function that takes a total and a number and adds those together is a pretty generic looking function. I could actually extract that out and reuse it later. So I'm going to extract this out and call this sum. So I'm going to make a function up here called sum, and I'm just going to make this a bit more generic. So given two values, A and B, we're just going to add those together. So now, instead of directly passing an arrow function into reduce, we can pass the reference to this function. Then we can use this function also below. So I can now take my mapped list of total item prices and come up with a grand total. So I have an array of many items and I want to reduce that down to a single item. So I'll do reduce and pass it my sum function. It's probably best practice to go ahead and initialize the starting value to 0 here, but it does have a default value that can serve you well in many cases. Now you'll notice here we have lots of other decimals. This is the joys of floating point numbers in JavaScript, but that is the actual total, minus 0.00001. Finally, let's answer our last question. How many baggable produce items are there? So we have a couple of different things here. Let's take it a step at a time. So how many baggable produce items? How about the first thing we do is let's filter our list down to just items that are produce. So I'll take my items and I will use the filter function to then filter where the items category is produce. Great, okay, we have 5 products that are produce. How many baggable items? So 5 is not my answer here. I want to know how many, the total quantities of all of this. So now I will take this filtered array, map over it, and just get the quantities. So let's map over this, each item, and get the item's quantity. So we're using both filter and map together here. Now I want how many baggable produce items. So I want the total of this list of numbers. So then I can use reduce and again before use my sum function that I'd previously created. And we have 12 baggable produce items. So in this example, we are using filter, map, and reduce all together to answer this question in quite a compact and really declarative manner. I'm not having to initialize variables and mutate them and update them. I'm not having to use for loops and count by indexes. It's really compact and declarative here, and this will look really nice in code. Well, there you go. Now you are a filter, map, and reduce pro. I encourage you to try these out in your own code and see what you can do with them. If you found this video helpful, drop me a like, I'd really appreciate it. And if you want to see more like this, then you can always subscribe to my channel. I do both recorded videos and live streams. So I'll see you next time.